Okay, this is Module 3, Homework 4, and we're going to be adding and subtracting and multiplying radical expressions. So in Module 3, Homework 3, we learned how to simplify radical expressions, and now we're going to use that in problems where we have to add and subtract and multiply. So the first thing that I want to make note of is how we look for like terms. So when we're talking about like terms, first we have to have matching variables. We have to have matching exponents. We need to have matching radicals. And we need to have matching indexes. So we're going to be looking at all of those things for each question. So this first one says add 3x plus 2x. This is 3x to the first, 2x to the first, so that's going to equal 5x to the first. Notice we are not adding these exponents. Our question starts with x to the first, and our answer is also x to the first. So the like terms match the answer that we got. So the next one, we have 3 square roots of x plus 2 square roots of x, which is going to give us 5 square roots of x. Notice the radical matches, the variable matches x and x, and these both have an index of 2. They're both square root. So those are like terms. The next one, we've got 3 square roots of x plus 2 cube roots of x, and those do not have matching indexes because this first one is a square root, the second one is a cubed root. So we cannot do anything with that. So it's going to stay 3 square roots of x plus 2 cube roots of x. We cannot combine anything there. So the next one, we've got the square root of 27 plus the square root of 75. Now we can't tell if they match until they're simplified. So we're going to use what we learned in the last section. We're going to take this 27, we're going to break it down to be 3 times 9. 9 breaks down to be 3 times 3. Notice this has an index of 2, it's square root. So we are looking for a group of 2, and we have 2 3s. So a 3 can come out, and then we have 1 3 by itself, so a 3 is going to stay underneath. Then we're going to do the same thing with 75. It's also an index of 2, so we're going to break 75 down to be 3 times 25. 25 breaks down to be 5 times 5, and again, we're looking for groups of 2. So this time we have 2 5s. So a 5 will come out. We have 1 3. So a 3 will stay underneath. And we're still going to add these two together. So now we see that we have 3 square roots of 3 plus 5 square roots of 3, which is going to give us 8 square roots of 3. Again, they have to match the radical. The exponents, the variables, the numbers, the index have to be exactly the same for us to add these terms, and our like term stays the same. So the square root of 3, square root of 3, our answer has the square root of 3 in it also. So now we're going to do one that's a little more complicated. We're going to simplify each one of these radicals individually. So the first one, we're going to do our factor tree. We get 2 times 12, 2 times 6, and 2 times 3. So that's going to give us negative 1 square root of 2 times 2 times 2 times 3. So we have 2 2's, so that shows us a 2 comes out. We've got 1 2 and 1 3 by itself. So now we have negative 1 times 2 with the square root of 2 times 3 underneath. Notice this negative 1 just hangs out in front. It comes down from our question, stays in front, comes down, it's being multiplied by whatever we brought out of the radical. So now we have negative 2 square roots of 6. So now we've got the next term. That's going to be 3 square root of 75. 75 breaks down to be 3 times 25. 25 is 5 times 5. So now we have negative 3 square root of 3 times 5 times 5. We are looking for groups of 2. So we have 2 5's here. So that tells us a 5 is going to come outside, and we're going to be left with the square root of 3. 3 will stay inside, and don't forget this negative 3 is going to be multiplied in the front. So we've got negative 3 times 5, which is negative 15 square root of 3. Now we need to look at the third radical. So we're just going to work our way down. 294 breaks down to be 7 times 42. Now you may have to grab your calculator and plug this in. You could also divide by 2, it's even. So you could break it down to be something else and you'll still get the right answer as long as you do the math correct. So now 42 is 6 times 7. 6 breaks down to be 2 times 3. So now we have plus 3 dropping down into our question. Then we have the square root of 2 times 3 times 7 times 7. Make sure you get every part of your factor tree. And we're looking for groups of 2. And we have 2 7's here. So that shows us a 7's going to come out. And we've got a 2 by itself and a 3 by itself. So those are going to stay underneath. So now we're going to bring this positive 3 down. And we've got a 7 coming out. And the square root of 2 times 3 staying underneath. So that's going to give us plus 21 square roots of 6. Now, we can't forget to come back up to our question to see if we have another term here. So we're going to bring that minus 4 square root of 3 down to the bottom. So don't forget that this drops down into our question. So now we can look for matching radicals. So first we have the square root of 6, and we have the square root of 6. Then we have the square root of 3 matching the square root of 3. So we've got 2 sets of like radicals. So we're going to take the number in front. Negative 2 plus 21 gives us 19 square roots of 6. And then we have negative 15 minus 4, which gives us negative 19 square roots of 3. Now, these don't match. Square root of 6 and the square root of 3 are not like terms, so we can't go any further. So this is going to be our final answer. Okay, this next question, we have one parenthesis with 2 terms, and we are subtracting another parenthesis with 2 terms. So this is really a subtraction problem. We're going to take this negative here and we're going to draw it as our imaginary -1, so then we can distribute that negative sign. So our first parenthesis is going to stay the same. Then we have a negative times a negative, which gives us a positive 5. Then we have a negative times a positive, which gives us a negative square root of 5. Once we do that, we're going to look for like terms. So we've got this square root of 5 matching this square root of 5. And then we have 2 numbers in here with no radicals, no variables. So we're just going to add and subtract those. So when we look at these radicals, this is a negative imaginary 1 and a negative imaginary 1. So we're really doing -1 minus 1, which equals -2 square roots of 5. And then we have -7 plus 5, which gives us -2. Now, sometimes when you put your answer in on our homework program, this -2 tries to sneak under the radical, and it's not supposed to be under there. So if it's easier for you, you can write the -2 without the radical first, and then write the -2 with the radical after that. That way, it's very clear that your radical stops here at the 5. Now, don't make the mistake of trying to add and subtract these 2 numbers in front. They're not like terms. This is one term, it has the square root of 5. This is the other term, it does not have the square root of 5. So we are finished here. Again, this question is all addition and subtraction, so we need to break down each radical separately first. So we have 147, which breaks down to be 3 times 49. 49 is 7 times 7. So this is going to give us 2 square roots of 3 times 7 times 7 times v times v. So now we are looking for groups of 2 because our index here in front of our radical is going to be a 2. It's square root. So we have 2 7s, so a 7 comes out. We've got 2 v's, so a v comes out. And that shows us that the 3 stays underneath. So now we have 2 times 7 times v with the square root of 3. This 2 is in front. That's the 7 we took out. That's the v we took out. And here's the 3 that stayed underneath. So this gives us 14v root 3. Now we're going to look at the next one. We have 108, which breaks down to be 2 times 54. 54 breaks down to be 2 times 27. 27 breaks down to be 3 times 9. 9 breaks down to be 3 times 3. So we're going to bring this 5v down. and that's going to give us under our radical 2 times 2 times 3 times 3 times 3. That's going to come from 2, 2, 3, 3, and 3. So again, our index here is a 2. So we're looking for groups of 2. So we have 2 2s. So we know a 2 is going to come out. We have 2 3s. So we know a 3 is going to come out. And we have 1 3 left over. So we know that's going to stay underneath. So now we have positive 5v times 2 times 3 with the square root of 3 left over. So the 5v comes down. Here's our 2 that came out. Here's our 3 that came out. And here's our 3 that stayed underneath. So now this gives us positive 5 times 2 is 10. And 10 times 3 is 30. So we get 30 v square root of 3. Now, that took a little bit more space than the first one. So I'm going to shrink it down and we're going to line these up good. So now we have 14v root 3 plus 30v root 3. And we have to simplify this last radical on the end. So we're going to break that one down. 48 breaks down to be 2 times 24. 24 breaks down to be 6 times 4. And 6 breaks down to be 3 times 2 and 2 times 2. So now we have negative 7 square root of 2 times 2 times 2 times 2 times 3. So make sure you have 1, 2, 3, 4 2's. We have 4 2's and then 1 3 here at the end. Now, we need to make a little bit more room because we can't forget our v squared. So we've got that v times v up at the top here. So we're going to bring v squared down. So now we're looking for groups of 2. We've got 2 2's. We've got 2 more 2's. We've got 2 v's. And then you'll see we have this 3 left over. So on the outside of our radical, we end up with negative 7 times 2 times 2 times v. And then we have the square root of 3 left underneath. And again, negative 7 comes down. Here's a 2, here's the other 2, and here's the v. So now that leaves us with negative 28v square root of 3. This negative 28v comes from multiplying those together. So now we need to look for like terms. So we have square root of 3. We have the square root of 3. And we have the square root of 3. So all 3 of our terms have the same square root of 3. And then we need to look at what's in front of them. We've got 14v plus 30v minus 28v, and that's all going to be in front of the square root of 3. So now that we see that these all have the same variable and they all have an exponent of 1, those are like terms. So we can do 14 plus 30 minus 28, and that's going to give us 16v, and the root 3 stays the same. Now, if these didn't all have the same letter, we would not be able to combine them. We would have to write them as separate radicals. So if we look at this for a second, let's just make a note and let's change the question to a different example. And let's say we had 3 square roots of 2 plus 5v square roots of 2. We can't add 3 and 5v because those are not like terms. So they all have to have v to the first for you to be able to combine them, like we had here, 14v, 30v, and negative 28v. So this one is a little more complicated. It has some fractions. So we're going to simplify the given radical expression completely into a single fraction. So how do we write something as a single fraction? So for us to do that, we need to get a common denominator. So first, we're going to simplify these the best that we can. We have the cube root of 5. We're going to break this apart to be over the cube root of 27. Now we have the cube root of 5 over 7. We can't do anything with that. So now we know we can't do the cube root of 5, but what is the cube root of 27? So you can do this a couple of ways. If you're still breaking things down with a factor tree, that's fine. We get the cube root of 3 times 3 times 3. We are looking for groups of 3, which we have. So that tells us the cube root of 27 is going to be 3, and there's nothing left underneath the radical. So this gives us the cube root of 5 over 3 minus the cube root of 5 over 7. So right here, we don't have a common denominator, but what is our common denominator going to be? We've got a 3 and a 7. So that tells us that our LCD between 3 and 7 is going to be a 21. So we're going to take this first fraction, we're going to multiply it by 7 over 7. And we do top times top, bottom times bottom. And that's going to give us 7 cube roots of 5 over 21. Then the second fraction, we're going to multiply it by 3 over 3. And again, top times top, bottom times bottom. So we're going to get negative 3 cube roots of 5 over 21. Notice, we did not multiply this 5 times this 3. The 5 is under the radical sign. The 3 is not, so all we can do is write it in front as multiplication here. So now we do have a common denominator, and we can take this equation. We're going to come up here, and we end up with 7 cube roots of 5 minus 3 cube roots of 5 all over that common denominator. And then we can see here that we have like radicals. So we have 7 minus 3, and that gives us 4 cube roots of 5 over 21. Now, we cannot simplify 4 over 21. Those are not divisible by the same thing. So this answer is finished, and we stop there. All right, the next one, here we have a parenthesis touching a parenthesis, and that tells us we are multiplying these together. So we're going to use FOIL, or we're going to just distribute. I like to distribute. I think it makes more sense. So we're going to write a lot of this out, so just get ready. We've got our first term, and we're going to multiply it by our first term and the next parenthesis. So that gives us 2 square root of x times 2 square root of x. Then we're going to take our first term and we're going to multiply it by the second term. So we've got 2 positive 2 square root of x times negative 3 square root of y. I'm going to give myself a little bit more room. Then we're going to start on the second term. The second term is positive 3 square root of y. So we're going to take this one and we're going to multiply it by the first term. Notice I did put parentheses around this one because it had a negative sign. This 2 is positive. You could put parentheses for the multiplication if you want, but you don't have to. And then we have the first term times the last term. So when we do that, you can see we have our yellow term times our orange term. Then we have our yellow term times our purple term. Then we have our green term times the orange term. And then the green term times the purple term. Okay, there's a lot going on, so we're going to do each piece individually. So looking at our first multiplication here at the beginning, we have 2 times 2, which gives us 4, and the square root of x times the square root of x is just x. Then we have 2 times negative 3, which is negative 6, and then we have the square root of x times the square root of y, which is the square root of xy. Then we have 3 times 2 again, which is positive 6. And we have the square root of y times the square root of x, which is the square root of xy. Or you could write it as yx. And then at the end here, we've got 3 times negative 3, which is negative 9. And the square root of y times the square root of y is just y by itself. So here in the middle, we can see that we do have matching radicals, and that makes these two middle terms like terms. Since we have a negative 6 and a positive 6, these are going to cancel out, and we're just going to be left with 4x minus 9y.